Hey, this is Don from Padlock Technologies again with another video. Got a question about site-to-site VPN theory. Someone needs a little help understanding it. Now, I'm going to give you an overview. Nothing's going to beat reading and labbing, but I'm going to give you an overview of site-to-site VPN theory that'll help you understand when you read about it, kind of, you know, understand it a little bit better, right? Because when I started learning this stuff and you read some of the documentation, it's very unclear. But I'm gonna break it down to you so that once you understand the high level concepts and then you go read about it, it makes more sense. So let's get to the whiteboard here. Let's start talking about site to site VPNs. So site to site VPNs. So the first thing you know is the why. So why are we even doing this? Okay. So the whole purpose of this is we're gonna have VPN heading over here, VPN heading over here. Private network over here, private network over here. And then we have the internet. I know I just spelled it wrong. Internet. So the whole purpose of this is to create a tunnel over a public network that is going to allow network one over here to communicate with network two over here. And nobody on the internet will be able to see that communication between these two, right? The communication between these two. So that's the whole point of this, right? Without this, you're going to need some kind of private circuit like MPLS, L2 VPN, or MPLS, L3 VPN, L2 VPNs, and those things are pretty expensive, right? So the average person, the average business can't really, like a small or medium sized business or really a small business, can't afford to just have a bunch of MPLS circuits all over the place. Now you can do things like DMVPN or SD-WAN or something like that, but that still utilizes this concept. But prior to those technologies, you really had either, VPNs like this or like private circuits. And most people couldn't afford private circuits that are smaller. Okay. So the whole point of site-to-site VPNs is allowing communication over a public network and having two private networks talk to each other. That's basically it. So, what are some of the components here in site-to-site VPNs? Well, you have two phases. You have phase one and you have phase two. So, what goes down in phase one? So, phase one is to secure the communication between the head ends, right? So, this is going to secure communication between head ends. And what I mean by head ends, basically, that is like the ASAs, the FTDs, the Palos, the Fortinets, two boxes, okay? So this is a secure communication between head ends, okay? So, what are some of the things that happens in phase one? Okay, so we're going to do our VPN head ends again, and we're strictly going to talk about the VPN head end. Okay, so what happens is we're going to exchange some algorithms, and we're going to run this one algorithm called Diffie-Hellman to get a symmetrical key for phase two. So Diffie-Hellman is basically asymmetrical keys exchange to get symmetrical keys. Okay, because it allows you to do that over a public network. It's a mathematical equation. So what we're going to have here in phase one, and I'll just do the tunnel here. A couple things we're going to do is we have our algo exchange. And what are these algos here? And I'm only going to do it on one side. It's basically for both. We have encryption. This is going to be, most of the time, is going to be AES encryption. And it's going to have some flavor of it, which is going to be either 128, 192, 256, or 512, something in that range. Then, if you're using IKEV1 or IKEV2, really depends, you're going to have this thing called a hash or integrity algorithm. Now, they're both the same thing, prevent modification of data, but they call them differently. IKEV1 calls it a hash algorithm. ICAV2 calls it an integrity algorithm. And this is where you're going to have your SHA or MD5. And you should not be using MD5 because it's more susceptible to collision attacks. And what that basically means is if you put two pieces of data in a hashing algorithm or integrity algorithm, they should have two different hashes, right? What the collision attack is basically, I take two pieces of data, I put them in the same collision, or I put them in the same hashing algo, and they come up with the same hash. That should not happen. If I have 1, 2, 3, 4, 5, 6, and then I put 1, 2, 3, 4, 5, 6, 7, it should be a different hash, right? But if they come up with the same hash, you got a problem. Okay. Next one is going to be Diffie-Hellman. Okay. And this is going to be that asymmetrical to symmetrical key, right? I'm going to do an exchange, and then I'm going to have a key material or symmetrical key for phase two, right? And this is either going to be in phase one, you can only pick one. In phase two, you can, pick, uh, I usually do three, right? Nowadays, you want to do either 20, 19, or 14, okay? So you're going to exchange that. And then you have your PSK. And this is to authenticate the VPN headends to each other. This is not, when I first learned this, I thought the PSK was the actual symmetrical key. That is not anywhere near the truth. This is just to authenticate the VPN headend. If they don't have the same pre-shared key, they're not going to be able to do any of this stuff. Okay? So that's what this is for, and I'll just put it here. Pre-shared key is to authenticate. Okay, so you're going to authenticate here. Okay? So once you authenticate the VPN headends, you run your encryption algorithm, you run Diffie-Hellman. Now you have the secure communication channel, and this is the secure communication channel is really to secure this exchange, the Diffie-Hellman key exchange, right? Because once you exchange that, and I'll just put Diffie-Hellman here. Once you exchange between the two, the next thing you're going to have is I'm going to have the symmetrical key or SIM key for phase two. Okay, so now we have the magic key that we need to actually protect the data. All right, so now that we have this SIM key, we are now ready to do phase two, which is the tunnel that's going to protect our data. So now we have phase two. And again, broad overview. I suggest you read up on this to make sure you understand like the ones and zeros of it, but at least having an understanding, high level understanding will help you understand that low level stuff. Okay, so phase two is protecting the actual data traffic. Protect data traffic. All right, so you're gonna have your VPN head in again. Your VPN head in again. Have another tunnel here. I'll make this a little bit shorter. Now, here's what you're gonna do in phase two. It's the same algo exchange. So you're still gonna do your algo run, which is your, encryption and hashing, hash or integrity. This is where you're going to pick, either ESP, AH, right? And those are different headers that you can have there. Now, ESP has a trailer as well, but um, these are just different forms, right? Now, there's no encryption with AH. This is just authentication. So you just got to be careful, right? But most of the time, 90% of the time, I would say 99% of the time, we're using ESP, right? Now, remember I told you about that SIM key, the symmetrical key you got from phase one, right? So here's the key that you got. And what is the point of phase one? Is to protect the communication so you can exchange this or you can get the symmetrical key. All right. Now you're going to take that symmetrical key that you got from phase one and you're going to use that with the encryption algorithm to protect the data. All right. So now you got data going through here. Okay, so that's the point of phase two. All right, you take the symmetrical key that you generated from phase one, you use that key in the encryption algorithm with your hashing algorithm, and that's how you're going to protect the data. Now, there is a thing where you can run Diffie-Hellman again called perfect forward secrecy. So this is called PFS here. I'll use you. So you could run PFS, which is technically running Diffie-Hellman again, to get a different SIM key or symmetrical key to protect the data. Now, the likelihood of somebody being able to run Diffie-Hellman and get the symmetrical key from phase one is relatively like non-existent. Why? Because you're protecting that communication. So first, they would need to be able to get through the phase one tunnel to see your Diffie-Hellman exchange to get the symmetrical key. The likelihood of that happening is pretty small. But if you want to be extra cautious, well then you run Diffie-Hellman again, which is perfect forward secrecy, and now you have a different key that's used to encapsulate or encrypt the data that's in phase two. So that's really phase one and phase two in a nutshell for site to site VPN. These are the components of a site to site VPN. You have to have phase one has to be established before phase two. And the reason why phase one needs to be established before phase two is because you need to get this. You need to get this key, right? You need to get the keying material. Some people call it that from phase one. You need to get the keying material from phase one to properly protect the data in phase two, right? Now, you can be extra cautious, like I said, and run PFS and run Diffie-Hellman again and get a different symmetrical key. And then you can use that to protect the data in phase two, okay? That is site to site VPN in a nutshell from a theory standpoint. So now that you understand the parts that go into site to site VPNs from a technical standpoint, not a configuration standpoint, but a concept standpoint, what are the things that can possibly go wrong here, right? To make the site to site VPN not come up. Now, I'm not going to give you any commands because, again, it depends on your vendor, and this is vendor agnostic. So I don't want to give you ASA or FTD commands because you may be working on a Fortinet and it's completely different. But one of the things that could go wrong, a couple of things that could go wrong, is the algorithm exchange in either or. Okay, so if you're using ICAV one, you have to have the policies, right? You have to have multiple policies because you cannot pick multiple encryption algorithms or hashing or integrity algorithms or Diffie-Hellman group algorithms in one policy. That's why that's why phase one is or phase two, not phase two. ICAV two is better than ICAV one from a configuration standpoint because you can configure multiple algorithms in one policy and then first match wins, right? If you don't have your algos are wrong, you're gonna have a problem there in phase one. And if phase one doesn't come up, you're not gonna have phase two come up. If Diffie-Hellman is 100% is wrong, well, again, you're not going to be able to do the correct exchange and come up with the same symmetrical key for phase two. So that's why your tunnel is not going to come up. If the PSK is wrong, you're not going to be able to authenticate the VPN head-end because you have the wrong PSK. And most people like zero in on PSK, right? Because, like I said, when I first started, doing site-to-site VPN tunnels, I thought that was the key that you're using to encrypt the data. Boy, was I wrong about that. So, if the PSK is wrong, you're not going to be able to authenticate the head-end. Therefore, all these exchanges are not going to happen. Okay. The other thing that you need to look out for is if you are doing this behind another device. If you're doing a site-to-site tunnel behind a firewall, well, you have to make sure NAT-T is enabled and supported. Now, for the most part, most firewalls nowadays or routers nowadays, NAT-T is turned on by default. So once it establishes that, hey, you're behind another device and I'm natting, then it will change ISO from 500 port 500 to 4500, and that's UDP. And what will end up happening is it established the site-to-site tunnel on NAT using NAT-T or NAT traverse versus just normal 500, which is just normal ISO account, at least the key exchange in phase one. will just establish on 4500 instead of 500. Now, it's important that you know these port numbers as well, because if you're blocking these port numbers on a firewall, then your phase one won't even establish because you're blocking either 500 or 4500 on the firewall itself. Most people, most people, when they do site-to-site VPNs, they're not behind the firewall, but there are some use cases where people will establish a site-to-site VPN behind the firewall, right? They'll do like a GRE tunnel or something like that behind a firewall or something like that off a router. So don't think that you won't go somewhere in an environment and they have a firewall in front and then they have a router and they're doing like an IPsec tunnel or a GRE tunnel and you're like, why are you doing that? You will see that out there. Um, from a phase two perspective, the things that can go wrong there, phase one is established. Well, phase two depends on what kind of VPN you are actually doing. If you're doing a route based style VPN, your traffic selector, which is basically your encryption domain, will be quad zeros, right? Because you're using routing. So it's not going to have a traffic selector that, interesting traffic that brings the tunnel up. If you're doing policy based, well, then you have to make sure your traffic selectors are correct. Meaning, what is the encryption domain? What is the network that you want to talk to the other network on the other side? That's going to initiate this tunnel. If they're wrong, then your tunnel is not going to come up, especially from a routing perspective. This is with routing all in play as well, right? If they're wrong, it won't bring up the tunnel, or it'll bring up the tunnel, but traffic won't go through because you have the wrong traffic selector, right? You might be going from 192.168, you want to talk to 192.168 2.0, and you got 1.0 that you're coming from, but in your site-to-site VPN, you have 4.0. Well, it's not going to hit the interesting traffic because you're going to 4.0, but the traffic selector says 192.168 1.0 going to 2.0. So from a configuration standpoint, you got to make sure that matches. Again, if you're using route-based style VPNs, it'll be quad zero, and you just got to make sure whatever dynamic routing protocol are you using a static route, but most people do dynamic routing. You're just advertising those subnets over the route-based style VPN, so it knows how to get there. Okay. In your phase two, you got to make sure you'll see something called a security parameter index. You'll need two of them. You'll need one for outbound and one for inbound, one for encapsulation, one for decapsulation. This is where if you do something, I'll use an ASA command. If you do show crypto, or not even an ASA command, it's really just a IPsec verification command. If you do something like show crypto IPsec SA, well, then you will see your traffic selector, you will see your security parameter index, you will see your encaps and decaps, stuff like that. If you see, you know, encapsulation, no decaps, there's something wrong with phase two. All right. Either an algo or something. Something's messed up with phase two. Normally you should see encaps and decaps there. And that, from a nutshell, from a real wide, high level overview of site to site VPNs. Now, I didn't discuss things like what kind of mode you're in because I'm making the assumption that you're using ICAV 2 for the question that you asked me. Now, if you're using ICAV 1, you have main mode versus aggressive mode, right? Difference between the two, you have 6 messages versus 4 messages. 6 messages out of in main mode, what happens is 6 messages go out. 4 of them are going to be plain text, 2 are going to be encrypted. And that's when you know you're up and running. Aggressive mode is 4, basically a lot faster to get to encryption. In ICAV 2, you have an init and an off stage, right? So init happens and then off and running. Again, high level overview. I suggest you read the books to get the real ones and zeros. This could be an hour long video if we really get into the ones and zeros about site to site VPNs. What else is there that I want to make sure that you are aware of with the site to site VPNs? I believe I covered mostly everything because depending on what you're establishing or what you're trying to do, route based versus policy based, will determine how you're going to configure it on the box that you're configuring in. So that is site to site VPN theory, high level theory in a nutshell. I'm going to put a video up here about a site to site VPN that I did I did it on a lot of boxes, so depending on which one I pick, it may be FTD, maybe Palo, maybe Fortinet. You don't know. But now that you know the theory, watching the configuration makes more sense because you're like, okay, he's establishing phase one here. Here's the algos he's running. Here's the why he's using a pre-shared key. Here's the phase two algo. Oh, he's running different Hellman again. That's perfect forward secrecy. Okay, he's gonna get a different symmetrical key for the data tunnel. Okay, you should be able to rattle this stuff off like that eventually when you start mastering site-to-site VPNs. So I hope that answered your question. If you like more stuff like this, I did a bunch of videos on different topics, different technologies, some overviews, stuff like that. But if you like stuff like this, go ahead and share, comment, like, and subscribe to the channel. If you are someone that is trying to get the concept of site to site VPNs, and you know somebody else that wanted to do this, share this video out to them, have them to join the channel and learn some other things because, again, I like doing this cool stuff and I really appreciate my channel growing and every sub I get. This is Don from Padlock Technologies again. Thank you and have a nice day.